In this video, we're going to take a look at the result type that was introduced in Swift 5 and see how we can use it as a clearer way of handling errors in complex code, such as asynchronous APIs. Using result, we can clear up any ambiguity and get typed errors as well. This will be a fairly lengthy video, but I want to go through this concept slowly and reinforce as we move along. If this is something you're interested in, keep watching. Before we start learning about the result type, I'd like to start by looking at a generic function that uses the URL session class for downloading data from different endpoints indicated by URLs. I built this function as part of my JSON and Codable protocol series on my YouTube channel. I'll leave a link to it in the notes. One of the videos in this series is JSON from API, and in this video we build the function that you see here. And before we change this function to use the result type, let me quickly step through the function and show you how it works. This will be quick, so if you want a slower walkthrough, please watch the series, as I'll not be going over JSON parsing or other concepts related to JSON and fetching data from an API. Links again are in the notes below. This function accepts a URL and completion function as parameters, with the completion function itself getting its argument, a decodable type, as a result of the URL session request. The generic type is optional because the retrieval may fail for one reason or other. It will be this optional generic type T that we want to be replacing with a result type in the next section. To use the function, we need a URL from which to retrieve our data and a decodable struct or class that will model the retrieved data via JSON decoder. Let's look at two different examples. The first reaches out to GitHub and retrieves all of the followers of Paul Hudson, who goes by the username 2straws. I've created this struct called GHFollower, and the data that's received in the request is an array of these GHFollower objects. We use the function by passing in our GitHub URL, and our completion function will have our decodable array of GHFollowers as an optional argument. We'll assign the array to followers, but because it's a generic parameter T can't be inferred, we must specify it here. We use iflet to check if it's nil, and then run a loop to list the followers' login names. The second example checks with the iTunes API and returns a single object that contains an array of results. Each result has interesting information about the items, such as artist name and the track name if it were an album, as an example. The iTunes URL that we have defined searches for 50 Beatles songs. So we can do the same as we did with the GitHub example by passing in the URL to our getJSON function and use the optional completion search results argument, an iTunes search object, to step through each of the results to print out the track name. And since the track name itself is optional, we can use the nil coalescer to deal with that. Both of these examples are covered in more detail in the JSON Codable series. So much for a review. It's working fine, so why change? I want you to note that all errors were dealt with in the getJSON function itself, and we only know if we have an error if our completion argument is nil. So there is no good way here to update the UI with any message corresponding to the error type. Well, let's introduce result to solve that problem. The first thing we're going to do is create a reusable utility or service class called network. By doing so, we can create a series of functions that can be accessed either through a singleton, static method, or, as we will use here, an instance of this class. If you're confused about static or utility class methods, check out my video on this. I'll leave a link in the notes below as well. Within the class, I'm going to create an error enum that will represent the different types of errors that I might get when I'm using the URL session. Each of these errors becomes a case in our enum which I'll call network error. I could have an invalid URL, some kind of decoding error, or some other generic error that I'll just call unknown error. Now let's return to our review playground and copy our getJSON function from there, and we'll paste it into our new network class. What we want to do now is modify it so that instead of our completion using an optional generic type, we want to use a result. So what is a result? A result in Swift is an enum with a success and failure case. Each has an associated value that will hold either the success value or an error if the result is a failure. Well, our success value is going to be our generic type T, and our failure type will be our newly defined error type. So we can replace T question mark with result, with the associated type T as our success, and network error as the failure associated type. Of course, this breaks things, so we'll need to update our error checks. If our URL string is not valid, we can complete with a failure result with the associated network error, invalid URL. If we get an error from our URL session request, then it could be any number of different types of errors, but I'm going to classify them all as unknown error types. Similarly, if we don't receive any data, our guard let fails, so we can use another failure completion with an unknown error associated type. Now, since both of these checks are giving an unknown failure error type, let's combine these two checks into this. Guard let error equals nil, comma, let data equal data, else completion, failure, unknown error. Now, if we've passed the invalid URL and unknown error checks, we must be at the point where we have received some data that we want to decode. We'll just use try question mark to assign the decoded data to decoded data. If you're confused about try and try question mark, take a look at my throw, try, catch video. I'll leave a link below. Since we now have used guard on error and data and have not had a failure, we are now at the point where we can decode our data. If it's nil, we have a decoding error, so we'll complete again with a failure decoding error. If it isn't nil, we have successfully decoded the data, so a result is a success, and we complete that with decoding data. And since we know it exists, we'll force unwrap it. Our function is updated. So now let's look how we can use it. We'll use the same request that we used in our review. To get toStraw's followers, we must first have an instance of network class to access the getJSON function. We'll pass in our GitHub URL, and note that our completion argument is a result. But, like before in our review, the result can't be inferred, so we need to specify that it is a result with a success associated type of array of GitHub follower, and the failures associated type is the network.network error. In our completion block, then, we can switch on whether or not the result is a success or failure. In the case of where it's a success, we get our array of GH_follower, which we can assign to the constant follower, and then loop through printing out our followers' login names. In the case where it's a failure, we can assign the error type to the error and then print out either the error type itself or the localized description. In a real app now, we would have our error and we can present valuable and relevant information to our users in our UI. If we run this app, we see we get our successful results. If I purposely mess up our GitHub URL by adding a space, we get a very specific error, which is our error type, along with the localized description. If I turn off the Wi-Fi on my computer and run again, I get an unknown error. I'll turn the Wi-Fi back on again. And this time I'm going to change the endpoint and call a different endpoint. The URL is still valid, but when I run the app, this time I get a decoding error. Let me quickly go through the iTunes search example. Let me type the code in first. This is very similar to the last example. We pass in our iTunes URL, and our completion function has a results argument that we have to specify as a result with an iTunes search success and network.network error failure. Switching on our two result cases, if success, we can loop through the results array of our iTunes search and print out the track name. And if failure, we can print out the error. Testing this with a valid URL, we get our expected results. Now, I don't like the fact that I have to specify the result type and error every time I make my network call. I'd like to embed that in my network class somehow, but keep that getJSON function itself reusable with generics. In the next section, we'll do some fine-tuning on this network class and also take a look at how we can deal with the different dates if our JSON data has a date key value pair. The first thing I'm going to do is copy our network class and use it in the next section. I'm not going to touch our getJSON function for now. Rather, I'm going to create specific functions for our different endpoints within the class. For example, let's create a function that will get the followers from the GitHub API. It will have a single closing completion parameter that will have a result argument. This will be a result that will have an array of GHFollower as the success and the network error as a failure, the same as our getJSON function, except that we are defining our success type here instead of being generic, and we don't need to include our class name for the network error. If you're confused about the @escaping keyword, I recommend that you watch my video on completion functions to get a better understanding. The endpoint for this particular function will always be the GitHub followers endpoint, so let's define it within the function. And now let's call the getJSON function passing in this URL, and the completion will be the specific one that we have just defined as our function parameter. Now this makes our function call so much easier. We can just do network.getFollower, and note that our completion result already knows what the success and failure types should be. No need to specify them here as they're no longer generic. Like in the previous example, we switch on result, and in the case of success, loop through the followers, printing out the login name, and in the case of failure, we'll print the error's localized description. Let's do the same for the iTunes search. We'll create a function called getITunesSearch, and this time our completion result argument will be a single iTunes search object for success, and as before, the network error as the failure case. We can define our iTunes search endpoint and pass it and our completion onto the getJSON function, like this. Calling the function is much easier again, as we see that our completion result type is now known. We can switch on the result, and in the case of success, we loop through the iTunes search results to print out the track names. And in the case of failure, we can deal with the here. We'll just print out the error. This makes it so much easier now to retrieve data from the endpoint. In fact, we can add more arguments to our functions without having to mess with the getJSON function. For example, let's add a user string argument to getFollowers. we can modify our GitHub URL now to use that argument, and instead of always finding toStraws followers, we'll be able to specify any user to find that user's followers. So we'll return to the GitHub example, and we see we now have to pass in the user string to our function. So let me see how many followers I have. Okay, not as many as Paul. There is a lot that you can do to make the getJSON function even more usable. So I want to leave you with one more example, and that is when you encounter dates in the JSON response. For example, here's a website that lists all upcoming rocket launches. It has an API that perhaps we can use. In the calendar section, I see that there is an endpoint that will fetch the next 5 launches. Let's try that out. Well, it looks like JSON to me. As we discussed in the JSON parsing series, you can use a JSON formatter like this one to get a better look at the JSON feed. I can use this information to build my class. All I'm interested in is the name and when the launch is. And I see that there are a number of different options for dates. Unfortunately, I don't recognize the format as one that I can easily use with JSON Decoder, except for this one. It looks like a number that would represent a number of seconds from a certain date, and that's what JSON Decoder expects as the default. So I'll use these 2 keys for my struct. In the sources folder for this playground, you can see that this is what I've done. The struct corresponds to the single object, launch calendar, that returns an array of launches from the launch object. All I'm interested in is the name and the window start timestamp. Let's build our function that will get that data. This should be easy now. Func get launches with an escaping completion argument, and we'll come back to that in a minute. So let's define our endpoint first. Now our completion argument will just be a result, with the success parameter being a launch calendar object, and the failure our trusty network error. Now let's get the JSON function by passing in the launch URL and our completion, just as we've done before. Now we can retrieve that information as we've done with our other examples. Network.getJSON, and our result type is known, so we can switch on that result. In the case of success, we get the launch calendar, and I can step through each launch and print the name and the launch timestamp. In the case of a failure, we'll print out our error type, which we can deal with in a real app. The function runs fine, but my dates are way off. What's going on? Well, I assumed that the date decoding strategy for the WS stamp was the default deferred to date, which is the number of seconds since January 1st, 2001. That's the default for the JSON decoder, when in fact, this is an epoch timestamp, and it's actually the number of seconds since 1970. So we have to use a date decoding strategy. What we can do then is add a new argument to our getJSON function that is an optional date decoding strategy, and set it to nil by default so that our other functions will still work. After all, not all of our JSON data has date keys. But then we can check to see if it's nil and add that requirement to our decoder. Back in the getLaunches function, we can add the new optional parameter, the .seconds since 1970. When we run our app once more, our dates are correct. That is, except for this last one. Why is that? Let's return to our data and scroll down to the last object. It turns out that the WS stamp is set to 0. I guess I'm going to have to somehow catch this in my code. That's for another day. Well, it just goes to show you that you can't always trust your JSON feeds. Well, that was a long video, but I wanted to take it slowly and build gradually. I hope you can see how useful the new result type can be in streamlining your code and allowing you to catch and respond to specific errors in your UI. I hope you found this video useful. If so, please give it a thumbs up below and subscribe to my channel. If I get enough positive feedback, I'll continue to build out similar tutorials for Swift developers who have left the starting gate but still need to add to their toolbox. You can check out my YouTube channel to see what other videos I've created. Visit my website to see my iOS app portfolio of apps currently on the App Store. And check out my GitHub repository to see what else I'm up to. Thanks for watching. I'm most active on Twitter, so follow me there for notifications of other Swift-related things that I'm up to.